Okay, in this video I'm going to do a problem from 8.12 that deals with radical equations. Also, I want to just show you today one thing that helps me stay organized, that helped me through high school, was writing down rules. If there's a new concept you've learned, then you need to be writing down the steps that they taught you so that you can look back at this when you come to these types of problems and remember what were those things that I was supposed to do to solve it. Make it very personal. I mean, I did copy. I took from 8.12's from Abeka's explanations here, but you can kind of write it in your own words, something that makes sense to you. For our rules, let's just do a problem. I'm going to do problem 13, and we're going to follow our steps, and you'll see how useful it is to write down rules for yourself, and kind of fun. I mean, you get to play with all kinds of fonts. Okay, so 13. The square root of 2x plus the square root of 2x minus 3. It's a cool idea to do a sample problem for yourself on your rule page. That way, when you're going back at test time looking at how to do it, you see the very problem that you worked to remind yourself. So anyway, our first step says isolate radical terms, most complex first. This is a radical term, this is a radical term. Obviously this one's the most complex, so we want it by itself. So I'm going to rewrite my problem. Square root of 2x minus 3. And for this one I'm going to change sides, change signs. It's a simple way of not having to write minus square root of 2x minus square root of 2x. You end up with the same term but the opposite sign. Change sides, change signs. Okay, so now I've isolated by most complex. What is the next step I wrote down from Abeka's rules? Raise both sides to free the radical. Okay, that's written in my own words. I know that with a square root, I'm going to need to square it in order to get it out. If it were a cubed root, you would need to cube it. Hopefully that makes sense to you already. So this side I'm going to square, this whole term, and this side I'm going to square. When you have equations, you have to do the same thing to both sides. Otherwise, you throw it off balance. So the square root of something squared just makes the something. For example, if I told you, I'll write it on a scrap piece of paper. If I told you, what is the square root of 16 squared? And trusting what I said, you would say, okay, well, she just told me the square root of anything squared is just the something inside. So you're going to trustingly write this. Great. If you want to know why, just work it out yourself. I gave you something easy. Square root of 16 squared is like saying, what's the square root of 16? 4 squared, which is 16. So either way, you're going to get the same answer. It just helps when you have these complicated terms like 2x minus 3. It helps to trustingly know, after proving it to yourself, that it will be 2x minus 3. Equals, okay, this one you are going to have to do some foiling. I'm going to do it right here. 1 times 1 is 1. 1 times negative square root of 2x is negative square root of 2x. Insides, negative square root of 2x again. Outsides makes a positive. Square root times square root makes just the number, a whole 2x. Okay, now I have 2x minus 3 equals 1. Let's combine these two similar terms, a negative 1 square root of 2x minus negative 1 square root of 2x. That's negative 2 square root of 2x plus a 2x. I see I have a positive 2x and a positive 2x on different sides of the equal sign. If I change sides, change signs with either one, they're going to cancel each other out. So I'm going to go ahead and do that. 1, let's take it, change sides, change signs, negative 1 minus 3. Negative 2 square root of 2x, okay? Combine these two, I get a negative 4 equals negative 2 times the square root of 2x. We're almost to having just a radical. I'm going to go ahead and divide both sides by negative 2. So I'll just have my radical by itself. So negative 2 can go into itself one time, or I'm just going to say 2 can go into itself one time, can go into 4 two times. Negative over negative cancels to positive, so I'm just left with 2 equals the square root of 2x. Now, back at our rules, we had isolate the radical term, most complex first. We did that. We've raised both sides to free the radical, and now the last step says solve. And I wrote there, solve with good old algebra. That's what we're doing right now. We're just using, we knew we were working towards getting the x alone, but look, that x and that x canceled, so we know that we're still working down our steps to work on this next radical. And actually, really, with this next radical, we're going to really work on solving for the x. That might have sounded a little complicated. All right, let's square both sides. And this will be a 2x, and this will be a 4. Okay? Oh, sorry. This will be a divide by 2, divide by 2. You're going to get x equals 4 over 2. That's just x equals 2. Now, before you circle that as your answer, you need to go back. Hopefully you will write something like this on your rule page, because Rebecca stressed it as well. Remember to check for extraneous solutions, or extraneous, I think they said extraneous roots. But I would advise you to look up extraneous roots in your glossary at the back of the book if you don't remember what they are. Extraneous root, a value found for the unknown number, x, in the solution of an equation that does not satisfy the equation. So the only way to know if our answer has satisfied the equation is to plug it back in. So if x really does equal 2, if I put a 2 everywhere there's an x, then my problem should come out perfectly perfect. Everything on this side should equal 1, because I did say all of this equals 1. So let's see if it's an extraneous solution or not. Make sure you can see what I'm writing here. Okay. Square root. I'm going to rewrite the whole problem as it was originally. Okay, original problem. Now I'm going to take wherever I wrote an x, now I'm going to write a 2. And just put a parentheses there and just fill it in with 2. We're not going to be changing any sides, because right now all we're doing is checking the truth of this statement. So square root of 2 times 2, that's square root of 4, that is 2, plus the square root of 4 minus 3 equals 1. Okay, we're still figuring out if it does equal 1. 2 plus the square root of 4 minus 3, that is the square root of 1, that's just 1 again. So is 2 plus 1 equal to 1? That is your final question. 2 plus 1 is 3. That is not a true statement. Equations are equal on one side is equal to the other if it's a true statement. So it does not work, and this really would be how you write your answer. 3 is not equal to 1, no solution. So your teacher hopefully will see that you found that x equals 2, that you found that that really x does not work, so that your final answer really that your teacher is going to want to see is no solution. And there you have it for working with radical equations. Some of your equations, they're going to come out equal and be just fine, but you do need to go in and check them and make sure by simply substituting. And remember, always try to give yourself a rule page for something new that you're learning, and that way you can go back and remind yourself how it's done.